The US spent years focusing on the chip itself. China just figured out that the box the chip goes in might be more important than the chip. Advanced packaging, chiplets, co-packaging, interconnects, accounts for roughly 30% of value in high-performance AI and HPC systems. Chips like NVIDIA's H100 and AMD's MI300. For broader semiconductors, that figure is lower, around 10 to 15%. But for the chips driving infrastructure expansion, the 30% figure matters most. And while Washington was watching TSMC and SMIC battle on node size, China quietly became the fastest growing player in a market nobody's paying attention to. This is Wafer Street. Here's what moved, and what it means for your money. The chip war narrative is all about nodes. 7 nanometer, 5 nanometer, 3 nanometer. Who can go smaller? Who can go faster? Who can scale first? That's the wrong fight. The real inflection point isn't what's inside the chip. It's how you package it, how you connect it to other chips, how you move data at speed across a multi-chip system without destroying power efficiency or adding latency. That's advanced packaging. And it's the part of the supply chain that's about to bifurcate at speed, and policy has barely noticed. Here's why it matters. Node technology now drives only 15 to 20% of generational performance gains, down from 50% or more a generation ago. The performance scaling benefit has flattened. Meanwhile, advanced packaging, interconnects, chiplet architecture, thermal management, that's where the real performance scaling is happening now. And while the US was restricting access to chip fabrication tools, China was quietly becoming the fastest growing player in advanced packaging. Packaging sounds boring. It's not. It's the difference between whether you can fit 10,000 GPUs in a data center or 100,000. Old school packaging. You make a chip, you put it in a plastic or ceramic case, you solder it to a circuit board. Done. Single chip per package. Works fine for a phone processor or a discrete GPU. Advanced packaging is different. Chiplets. Multiple smaller chips bonded together in a single package, communicating at speeds that rival on-chip communication. No latency penalty for going between chips. All the redundancy and design flexibility of multiple smaller pieces, with none of the performance tax of traditional multi-chip modules. JCET Group, China's largest OSAT, announced full high-volume manufacturing for its XDFOI multidimensional heterogeneous integration chiplet platform. They're utilizing RDL interposers, silicon interposers, and silicon bridges. They've also delivered customer samples for co-packaged optics architectures. Why? Because while the US was restricting access to lithography tools and fabrication equipment, packaging capabilities scaled faster than anyone anticipated. Here's the competitive landscape. ASE Group leads globally from Taiwan. Amkor is the top US player, and JCET Group, China's packaging giant, acquired Stats ChipPack back in 2015. So the market that used to be split between Taiwan and the US is now split 3 ways, with China holding the 3rd position and closing the gap faster than expected. Chinese competitors like JCET and Tongfu Microelectronics are now closing the technical gap with Taiwan's ASE and US-based Amkor. That compression happened in 18 months, not years, 18 months. Here's what actually accelerated the timeline: demand from Chinese hyperscalers for higher chip densities. When Alibaba, ByteDance, and Tencent all announced they were building domestic AI clusters, they faced a problem. They couldn't get the highest-end GPUs from NVIDIA, so they needed to figure out how to build AI infrastructure using domestic chips that could match NVIDIA's density and performance per watt. The only way to do that without waiting for Chinese fabs to reach cutting-edge nodes was to package multiple lower-node chips together in a way that acts like a single higher-performance chip. Advanced packaging was the answer, and the demand signal was so strong that Chinese packaging companies went from aspirational players to competitive players in 18 months. ByteDance alone needs thousands of AI accelerators for its internal infrastructure and for selling to other companies. Alibaba's cloud infrastructure requires massive clustering capability. Tencent needs density to hit its cost targets. All 3 of them turned to domestic packaging as the solution, and domestic packaging capabilities accelerated to meet them. This is what happens when you have a captive hyperscaler market pulling as hard as it can on your supply chain. The demand signal creates urgency. The urgency creates innovation. The innovation creates capability. Here's where the story becomes about policy failure rather than market dynamics. The US export control regime was built around machines, lithography tools, etching equipment, testing gear. The entire architecture of control sits on the assumption that you can restrict capability by restricting the tools that build chips. But packaging doesn't require cutting-edge lithography. It requires precision bonding equipment, advanced wafer handling tools, and thermal management expertise. Early export controls focused on front-end lithography and didn't restrict packaging tools. That was oversight. But in 2023, the U.S. Commerce Department expanded restrictions to include advanced packaging equipment. Specifically, ECCN 3B001.C.4 restricts etching equipment for through-silicon vias with aspect ratios greater than or equal to 10:1. ECCN 3B001.D.3 restricts atomic layer deposition and surface treatment tools for high-density hybrid bonding. Those are the core technologies for advanced chiplet packaging. So while packaging was initially overlooked as a policy blind spot, controls have since caught up. But by then, Chinese companies had already scaled their capabilities and locked in domestic hyperscaler demand. That's the real policy failure. The controls came too late to prevent Chinese infrastructure from going domestic. Once Alibaba and ByteDance committed to domestic packaging for their AI clusters, the supply chain bifurcation became permanent. You can't unscale a supply chain that's already scaled. So here's what comes next. The supply chain bifurcates not just on nodes, but on packaging architecture. Western companies will continue to use ASE, Amkor, and other established advanced packaging providers. Those are proven, reliable, integrated with Western design tools and supply chains. Chinese companies will continue to accelerate their own packaging infrastructure. Not as good as Western options yet, maybe, but good enough. And good enough is the new strategic baseline when the alternative is depending on foreign supply chains that can be restricted at any time. Meanwhile, companies like NVIDIA and AMD have to decide, do we continue to design around advanced packaging standards that assume Western assembly houses? Or do we design modularly enough that chips can be packaged either way? That's the real strategic question. Not whether China has caught up to Taiwan in packaging. The question is whether the industry bifurcates into two incompatible packaging ecosystems, and if so, when. Timeline. Chinese packaging capabilities are already considered reliable first-choice suppliers for domestic Chinese cloud providers operating under sanctions. By 2027 to 2028, expect them to reach broad volume parity with Western OSATs for standard advanced packaging applications. That's fast. That's faster than most semiconductor industry transitions, and it's happening right now while policy is still talking about node restrictions. For policy operators, this is evidence that export controls work best when they're broad-based and anticipatory, not reactive. By the time you restrict access to one tool or technology, the industry has already started working around it. Packaging was the workaround nobody saw coming because it didn't fit the traditional chip war narrative. That blindness will happen again on the next layer you haven't thought to restrict yet. Controls expanded to packaging too late. The pattern will repeat unless policy gets ahead of the supply chain, not behind it. For retail investors, the companies building advanced packaging infrastructure in China are not household names. They're not public, but they're growing at 20 to 30% annually, capturing margin that used to flow to Western assembly houses. If you have exposure to semiconductor supply chain plays, watch packaging capacity utilization and domestic hyperscaler commitments, not just fab utilization. The economics are shifting faster than the headlines suggest. For tech and AI operators, if your infrastructure plans assume you can always source from Western advanced packaging providers, this quarter is telling you to hedge that assumption. Start qualifying domestic packaging alternatives now, even if they're not your first choice. By 2027, they might be your only choice for certain applications. The bifurcation is already baked in for Chinese hyperscalers. It's coming for everyone else faster than expected. Before you go, here are 3 numbers to keep in your back pocket from this one. First number, 30%. That's the value add that advanced packaging represents in high-performance AI and HPC systems now. Not nodes, not just the chip itself, the packaging, the interconnects, the multi-die architecture. Second number, 18 months. That's how long it took Chinese packaging companies to go from aspirational players to competitive players. 18 months. That's the speed of supply chain compression when you have captive domestic demand. Third number, 2027 to 2028. That's when expect to see Chinese advanced packaging technologies reach volume parity with Western OSATs for standard applications. Once that happens, the bifurcation becomes permanent. The supply chains don't rejoin. Here's the question I'm sitting with, and I want to know what you think. When does your supply chain strategy need to account for bifurcated packaging ecosystems? Is that already happening in your infrastructure decisions, or are you still assuming Western packaging access is guaranteed? Drop your read in the comments. This is the conversation that matters. Here's my read. This is what supply chain bifurcation actually looks like before it becomes obvious. It's not a dramatic overnight split. It's a gradual shift where a Chinese company quietly becomes good enough at something the West took for granted, and suddenly you can't assume access anymore. By the time policy notices and tries to restrict it, the infrastructure's already domestic, and the companies relying on it have already adapted. Packaging is just the first place where this plays out. It won't be the last. The pattern is clear now. Export controls create demand for domestic alternatives. Domestic alternatives get built faster than expected when there's a captive market pulling as hard as it can. By the time policy catches up and restricts the tools, the capability has already bifurcated. But here's what changes with packaging. The restrictions came faster this time. BIS added packaging tools to the control list. The problem is, they came after the infrastructure already went domestic. And that's the asymmetry. Policy is getting faster at reacting, but the supply chain is getting faster at moving, and right now supply chain speed is winning. That's where the money moves. If this kind of supply chain analysis is landing with you, hit subscribe. New episodes drop every Wednesday. This is where we break down the policy moves to what they actually mean for your infrastructure, your portfolio, your supply chain strategy. Like and share if the bifurcation story is resonating with your team. The more people tracking this, the faster we adapt. Follow the money. Follow the channel. See you next time.